All right, welcome back. So in the last one, we were talking about histograms and proper bin sizes and how it's just kind of up to you. And then in this one, we're talking about scatterplots. Okay. Now scatterplots are used all the time to show, here we go, relationships, and I'm going to say correlations, but not, oh man, but not causes. Okay, that's a big thing. That's a big thing. You hear that all the time. Just because there's a correlation doesn't mean that there's a causation, right? It's overused, but it's true. Okay, so we use these scatter plots to show the relationship between two numeric variables. Okay, now in our case, our scientist wants to know how age and muscle density changes. Okay, or how age affects muscle density. And I'll show you how to plot that here in just a moment. So we've got some base R stuff. I'm not even going to show you how to do this because the moment you want to add a line in this, it just turns into a big hullabaloo. So let's just go ahead and get into ggplot here. Let me clear away this histogram we made. It looks pretty okay. Let me clear away the console too, and let me get rid of that. Okay, cool. So here we go. We are making now a scatter plot of age versus density, muscle density. Okay, how are we going to do this in ggplot? Okay, well, again, like always, we need to add our base layer, okay, and that's just going to be made up of the data that we have. That's muscle, and it's going to be made up of our aesthetics. Okay, so in this case, we want an X and a Y. In histograms, we only wanted an X, and in box plots, box plots, we wanted a categorical X and a numeric Y. Okay, but in this case, in the case of scatter plots, we are needing two numeric things. So we specify the aesthetic, okay, and we want an X and we want a Y. Okay, now this is sort of up to you as far as the order. However, I will say that usually the thing that you want to see, usually a thing that is affected is the thing that's on the Y-axis. So that in our case would be density. That's typically your outcome, the thing that you want to see change. Okay, now for our x-axis, that's just going to be age, okay? Because that's the thing, we want to see how age affects the outcome, how age affects the density. So age goes on our x-axis and density goes on our y-axis. Density also is the start of many other functions in R, but that's okay. So if I run that, check it out. So I get age on the x and density on the y. How age affects density, how x affects y, how x changes y, this whole thing, right? You could flip it around, but that kind of makes interpretation just a little bit more difficult because that's not the question we're asking, okay? Very cool. Okay, so then we want the ice cream. We've got the bowl, we want the ice cream. And we worked with histograms, that was geom histogram. We worked with box plots, that was geom box plots. In this case, we want to work with scatter plots or a point plot, geom point. Okay, easy enough, easy enough. Does anything go in here? Well, for right now, big no. Okay, and if I just run this, check it out. So it plots every point on here. So this person here was like 59 years old and had a density of 70 units. This person here was, I don't know, 57 and had a density of 79, so on and so forth, right? So each one of these points represents the measurement for one person for these two things, okay, for age and density. And already we get a pretty good idea of the relationship between these two things. And when we get into regression a few weeks from now, a couple months from now, we'll be able to quantify this relationship and determine if this relationship is true for everybody in this age range, not just these people, okay? Anyway, we already have a pretty good idea of the relationship. As age increases, density decreases. And if you're a biologist or a physiologist or a kinesiologist or whatever, this might be pretty intuitive, or at least not that surprising. But if you're totally naive to this idea, which is totally fine, we already have an idea of that kind of inverse relationship, this kind of negative slope here. Okay, already this is fine. We could say, here you go, give me my 20K or whatever. But I think they asked, for a line as well. They asked for a line. Okay, so that's pretty easy to do. That is pretty easy to do. What we're gonna do is just add in another thing that we want on top. Excuse me, sorry. Talking forever really does it to my throat. And I'm yelling here. I've got the Zoom voice on. So anyway, we want to add something on top of the dots. We want to add something on top of these points. And that is going to look like a geom of something. But what's it going to be? It's not going to be an ab line. And it's not going to be, I think I was using kind of the word line here. And there is a geom line. If I run this, okay, I keep making that noise a lot. That's kind of like the no-go noise. This connects the dots. This is not helpful for us in our sense. It is helpful when you're working with time, not age, but like actual like December, January, February, March kind of thing, connecting the dots like that. But we're probably never going to do that, at least in this class, at least. Okay, so we don't want geom line. What do we want? So I removed geom line and hit tab just to give me all the options here. And it turns out that I actually want geom smooth. Geom smooth. Okay. What the heck? Why is it called smooth? Well, I'll show you. So if I run this as is, takes a second. Look at that. So it draws a line, but it doesn't draw a straight line. In fact, it draws what's called a Loess line. And all of this is, what this is really doing is it's just, it's drawing a straight line for a little tiny bit of the data, and then drawing another straight line for a little bit of tiny bit of the data, and then connecting them and then smoothing those straight lines. It's helpful sometimes, sort of. In our case, it's okay, I think, but we don't get to see the kind of linear relationship. We see this sort of reweighted linear relationship. Again, not totally important. You understand the math and how it does it, but we do see that it kind of characterizes the kind of dip here. It does kind of characterize the fact that there is a tiny, tiny little dip as you grow older, as density changes. Okay, don't so much worry about the shading for now. When we get into regression and actual analysis, this will come into play, but for right now, it does not matter. How do we fix this? I don't want a curved line. I actually just want a straight line. That's often what we want in statistics. We estimate a lot of things and a lot of relationships with a straight line because that's the easiest to interpret, which we'll get to when we get into regression. Well, let's take a look at this message that it gave us down here. So geom smooth, which is the thing right here, is using method equals Loess. Okay, so the method that it's plotting this line here, this smooth line here, is this method. I don't I don't want that. I want the method to be something different. I want it to be a linear thing. I want it to be a line rather than a curved thing. Well, if I come here and hit tab, and then it gives me all the options for the arguments, let's just hover over method for a second, and let's read. Smoothing method function to use accepts either null or a character vector. Blah, blah, blah. That's just a fancy way of letting you know that you can specify something in quotation marks. And it gives you the options here, all of the options for this argument. We have LM, GLM, GAM, general additive model, and Loess. By default, it uses the Loess. Let's go ahead and specify one of these other things. Now, I said that I wanted it as a line, and to me, LM, that stands for linear model, LM linear model. If I just type in LM here, because that was one of the options it gave, and run that, booyah. It now gives me a straight line that's a little bit easier to kind of see that relationship. Now, again, this is what's used in statistics, and we're going to be using this all the time in this class. But there are some instances where you do want to see that dip. In our case, and like totally subjective and totally up to you, that dip wasn't big enough for me to think that I need to incorporate it into the plot. It was just, there's some points down here that are kind of pulling the line down a little bit more than there are above. Again, not enough for me to really care about about that. So a straight line here is totally fine. It's totally fine. And this is good enough. This is good enough. And let me just kind of clean it up just a little bit more. Theme, old classic. Cool. And that looks pretty smooth, right? That looks pretty smooth. And so what do? Just as a little recap, we put, actually, instead of me, actually, yeah, no, I'll do that in a different video. So sorry, I'm thinking out loud here. So we've got our base layer, and then we've got the points, got the geom point, and that just tells the computer to say, hey, put the points on here for each age, for each person, and their age and density, muscle density. And then we use the geom smooth to plot the line with method equals linear model. If I were to come in here and specify Lois again, it would draw the curved thing. If I were to do gam, I believe that'll also do, yeah, it's a slightly different curve. And by slightly, I mean like microscopically slightly. Anyway, a lot of these do kind of do the same thing. That's the GLM one, whatever. It's no big deal. We're going to stick with LM. So when you're copying and pasting this code, this is the method we're going to be using most of the time. And then the theme underscore classic just makes it look pretty. Easy as that. So in just a couple of lines here, again, spacing doesn't matter. I could put this all on one big line and be not too organized, but it would still work. It would still work. But in just these few lines, we made a pretty decent looking plot here. We made a pretty decent looking plot. Now, I'm going to make a new video because there's something in this that we can make this a little bit better, I think. We can make this just a tiny bit better because we're not encapsulating the full story here. We're only encapsulating the relationship of age and density, leaving out the fact that we also collected the sex of these people, okay? Maybe it's different between males and females. Maybe. We're not capturing that though. So with that being said, a little cliffhanger. I'll see you in the next one.